Alright guys, back to the June 2016. I'm looking at question 25. Given that f of x equals 2x plus 1, find g of x if g equals this. So, I want to take g of x, and I'm going to just replace. I'm just substituting in this equation. I have a 2, and then in brackets, I need to put f of x. Well, what does f of x equal? 2x plus 1. So I replace it with 2x plus 1 squared minus 1. And that's it. This question, I remember when we graded this a couple years ago, a lot of students tried to simplify this from here, and that's where they ended up losing credit because they made mistakes when simplifying. They just asked you to find g of x. I did it. It doesn't say that I have to simplify. So I'm going to stop right there, and that's my final answer. 26. Determine if the product of this and this is rational or irrational. All right, how many times have we done this? So product means you're multiplying. So the first thing I'm going to do is put this on my calculator and see what I get. So what do I have? Let's see here. 3 radical 2 times 8 radical 18, and I get 144. And I have to explain my answer. The product is rational because 144 is a number that can be written as a fraction. Now remember, this isn't the only explanation. You could say that 144, there's no decimal, or I mean, there's a number of ways that you can explain it. What makes a rational number rational? The decimal is 0.0. I have a decimal that ends, or a decimal that's not there. I have a number that can be written as a fraction. So anything like that you can say. Question 27. On the set of axes, draw the graph, and then I have to do something else after. Okay. Well, any question that I get that I'm graphing, I'm going to my calculator. Always, always, always. X squared minus 4x minus 1. I'm going to my table. This is an x squared. That means it's going to be a parabola. I'm going to look for the rainbow in the table, and I'm going to graph that. And there we go. So I've got a bunch of points here. I'm going to graph whatever I can fit on my page. Negative 2, 11. Okay, so my graph paper only goes up to 10, so I'm not going to graph that point. So let's see here. Negative 1, 4. 0, negative 1, 1, negative 4, 2, negative 5, 3, negative 4, 4, negative 1, 5, 4. So then if I look at my picture, because at least my calculator will give me an idea of what this should look like, and it should match what I have. So I'm just going to draw that U shape as well. Remember, this graph continues, so you got to throw arrows on the ends. So there's my parabola. And then it says state the equation of the axis of symmetry. All right, we just talked about this in class. The axis of symmetry is the line that cuts through the center of the parabola. This is my turning point. This is my vertex. That is the point 2, negative 5. The axis of symmetry, focus on that x. X equals, and it's the x coordinate of your turning point. So x equals 2 is your axis of symmetry. Right. 28. Amy solved the equation. She stated the solutions of the equation were 7/2 and negative 6. Do you agree? And explain why or why not. So there's a couple different things I could do. I could go through and solve this myself and see if I get the same answers. Or I can just check to see if these answers work. So you can do whatever you want. I'm going to check them. So if I look at this, 2, and then I'm going to put a 7 over 2. So I'm going to check this answer first. All of my x's will turn into 7 over 2. So 2x squared plus 5 times 7 over 2 minus 42 equals 0. I'm going to put that on my calculator. Let's see if it checks. Let's see, 7 over 2 minus 42, and I get a 0. So I've got 0 equals 0. That checks. So then I'm going to do it again with negative 6. So let's see if that one checks. So I put all my x's, I turned them into negative 6's. 2 times negative 6 squared plus 5 times negative 6 minus 42. And I also get 0 over 0. So I could say, yes, I agree with Amy because both of her solutions check. Okay, now let's say I didn't want to do that. Let's say I solved the equation. So her equation is 2x squared plus 5x minus 42 equals 0. If I solve for x, I can factor, I can complete the square, or I can use quadratic formula. I'm going to use quadratic formula. It's easiest, I think, because I don't have to memorize it, and it always works. Factoring doesn't always work. So I've got a, b, and c, 2, 5, and negative 42. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So there's my formula. Remember, it's on your reference sheet. So x equals negative 5 plus or minus the square root. So on my calculator, I'm putting everything that's under the radical, not the radical, just the numbers that are underneath. 5 squared minus 4 times 2 times negative 42, and I've got 361 over 4. So now what I want to do is I want to check, is 361 a perfect square? And it is. The square root is 19. So x equals negative 5 plus or minus 19 over 4. Now I can branch this. So I can do negative 5 plus 19 divided by 4, and I've got, let's see here, 7 over 2, negative 5 minus 19 divided by 4, and I've got negative 6. So now I can say, I agree with Amy because I solved the equation and got the same answers. Two different ways to do the exact same problem. Okay? So you could either check her answers to see if they work and explain that, or you can solve it yourself and explain it that way. So it all depends on what you feel comfortable with. Okay. Question 29. Sue and Kathy were doing their algebra homework. They were asked to write the equation of the line that passes through the points. Sue wrote one equation, Kathy wrote another. Justify why both students are correct. Now remember, justify means I can do math if I want, I can write sentences if I want, I just have to back up my answer. Well, here's what I'm going to do with this one. I've got 2 points and I've got 2 equations. I need to check that everything works in everything. So I've got Sue and her equation, y minus 4 equals negative 1/3 x plus 3. And I've got Kathy. Y equals negative 1/3 x plus 3. I'm going to see if the point, so the first one I'm going to check, negative 3, 4. I'm going to check it in Sue's equation, and then I'm going to check it in Kathy's equation. So remember, this is x, this is y. Four minus 4 is 0. Negative 3 plus 3 is 0. 0 times anything is 0. So that checks. Now I'm going to take the same point and substitute into Kathy's equation. Get my calculator out for this one. Negative 1/3 times negative 3 plus 3, and I've got a 4. So that checks. Now I'm going to take the point 6, 1 and check it in Sue, and then check it in Kathy. So remember, this is x, this is y. One minus 4, negative 3 equals negative 1/3 times 6 plus 3. That one checks. Now I have to check this point in Kathy's equation. So I'll go to my calculator. Negative 1/3 times 6 plus 3 equals 1. Alrighty, so justify why both students are correct. Both points check in both equations. Now remember, justifying means you need something to back up your answer. All of this work here backs up my answer that yes, they are correct. So all of that work counts. I don't have to write any formal sentences there. Alrighty, question 30. During a recent snowstorm in Red Hook, Jamie noted that there were 4 inches of snow on the ground at 3, and there were 6 inches of snow on the ground at 7. If she were to graph this data, what does the slope of the line connecting these 2 points represent? Well, if you think about slope, that's change in y over change in x. Now, the 2 things that we're measuring are the inches of snow and time. And where do we always put time? Time is always our x. So time is on the bottom, and then our snow is on top. So if you think about this, there were 4 inches of snow at 3 p.m. There were 6 inches of snow at 7 p.m. So how much snow fell? Well, we went from 4 inches to 6 inches. So 2 inches over, well, what about the time? The time went from 3 p.m. to 7 p.m. So that's 4 hours. So if you just reduce this, you could say that that's 1 inch of snow every 2 hours. So now, what do I have to do? If she were to graph this, represent, what does the slope of the line connecting these 2 points represent in the context of the problem? The slope represents how much the snow falls every hour. So if you look at this, if you keep reducing this fraction, I have 1 inch of snow in 2 hours, so then how much snow is going to fall in 1 hour? Well, if I cut this in half to 1 hour, then that means that I'll have 1/2 inch of snow falls every 1 hour. So it's really just manipulating this. The formula for the sum of the degree measures of the interior angles of a polygon is this. Solve for n, the number of sides. Okay. Nobody cares about the degree measures of the angles. All I care about is I have an equation and I have to solve for n. I have to get n by itself. So I'm going to distribute. Now I'm going to add 360. And if I want to get n by itself, divide by 180. And that's it. And let's see here. This is our last 2-point question. In the diagram below, f of x is graphed. So this top equation right here, this is f of x. Also graphed is g of x. So g of x, is underneath. The result of a translation. Okay. Determine an equation for g of x and explain your reasoning. I'm actually going to explain it first and see if that helps us write the equation. So if I look at f and I look at g, what happened? What happened to f that turned it into g? Well, I would say g of x is the same graph as f of x, but moved down 4 units. This graph, if you look at these two graphs, they're the exact same curve, except look at this point that was here is now down 4. This point right here is now down 4. So everything that happened, if you take f of x and just slide it down 4 units, that's what g of x is. So now, I have to write an equation. Well, when you move down 4 units, that means you need a minus 4 at the end. G of x is f of x, it's the same thing, down 4 units. And that's it. That's all you need. I have a little explanation and I have my equation. And I actually think the explanation helps me get the equation. All right, there you go.